So today we'll discuss about CLT in brief. Okay. So CLT, central limit theorem. This is a statistical theorem. Just read the statement carefully. Okay. Every word explains a particular meaning. Okay. So this is statistical theorem helps to estimate population parameter from sample statistic. Means अगर हमारे पास कुछ सैम्पल डेटा है या सैम्पल स्टैटिस्टिक है तो हम उससे पॉपुलेशन पैरामीटर्स को निकालेंगे. ठीक है, मीन्स हम सिंपल डेटा से फ्रॉम द सैम्पल डेटा वी आर estimating the population parameter. Okay, so CLT tells statistical theorem that helps to estimate population parameter from sample statistic. जब हम सैम्पलिंग करते हैं तो ये पॉपुलेशन है, ये सैम्पल है, हमने कोई रिसर्च करी, इसका डेटा निकाला तो कुछ रिजल्ट्स आए, तो अब हम उससे कह रहे हैं कि हम इस रिजल्ट के या इस डेटा से हम पॉपुलेशंस के पैरामीटर्स जो भी इसका डेटा है उसको एस्टिमेट कर सकते हैं या फिर उसको एस्टिमेट करने में हेल्प करता है. ठीक है, और also it tells about the nature of sampling distribution based on the individual sample size. It simply tell about how the sample is distributed. Okay, so now there are three statements. Okay, we'll just go through these once. If a sample size of individual sample is 30 or more than 30, then the sampling distribution will be normally distributed irrespective of nature of distribution of the individual sample. Okay, let's go through this. So just focus on this sentence. Size of individual sample is 30 or more than 30 means जब एक individual sample का size 30 और 30 से ज़्यादा है, okay, ये हम assume कर रहे हैं, sample size is equal to or greater than 30, then the sampling distribution will be normally distributed. Means जब ऐसा हमारी कंडीशन हो रही है तो सैम्पल क्या है, नॉर्मल डिस्ट्रीब्यूटेड है. नॉर्मल डिस्ट्रीब्यूटेड की हम कंडीशन कैरेक्टरिस्टिक पढ़ेंगे. ठीक है, चाहे वो उसका नेचर ऑफ डिस्ट्रीब्यूशन कुछ भी हो, रिस्पेक्टिव ऑफ द नेचर ऑफ डिस्ट्रीब्यूशन ऑफ इंडिविजुअल सैम्पल. सैम्पल साइज ऑफ अ इंडिविजुअल सैम्पल 30 और ग्रेटर देन और इक्वल टू 30 है तो वो नॉर्मल डिस्ट्रीब्यूशन होगा इररिस्पेक्टिव ऑफ इंडिविजुअल सैम्पल. ठीक है, तो ये ग्राफ है नॉर्मल डिस्ट्रीब्यूशन का. ठीक है, यहाँ पर जैसे दिया है, अ बेल शेप डिस्ट्रीब्यूशन इज कॉल्ड अ नॉर्मल डिस्ट्रीब्यूशन. ओके, जब हम नॉर्मल डिस्ट्रीब्यूशन को ग्राफ से बताते हैं तो एक बेल शेप कर्व होता है. ठीक है, अब इसमें बात करते हैं हम 1 2 3 1 2 3. जस्ट अज्यूम दिस बोथ राइट एंड लेफ्ट आर इक्वल. ओके, 1 2 3 1 2 3. So it's saying 68% of data points within plus minus 1 standard deviation. So this line x-axis is called standard deviation. The center will be mean, mode, median if the data is normally distributed, and this is called the spread. Okay, this is 1 2 3. Spread is we calculate it from the standard deviation. Okay, तो जो ये 1 है, okay, it's saying कि जो ये 1 पोर्शन ये कंटेन करता है 68 डेटा पॉइंट. इट्स जस्ट अ मैथमेटिकल कैलकुलेशन. ओके, एंड 2 when we say a 2 standard deviation, so it's completing approx 95% of data, and when we come approx to 3 standard deviation, so it completes or it covers up to 99.7% data. It's just a graphical data set. Okay, and it's saying the fourth sentence, deviation from normality is skewness and kurtosis. Skewness, like this is normal data, bell shaped curve, but when it is deviated, the data is deviated, then we say is skewness or kurtosis. Okay, so skewness is like when data is either to the right, okay, this right side has a length, and when the left side has a more length, that is known as skewness. And kurtosis, like assume this is normal range, it can go vertically high, this is positive, and this is negative down. Okay, so this is the deviation. Skewness, so in like vertical formation, sorry, horizontal, either to the right or left, This is shown as vertical, either up or down. Okay, hope you got this. Now some properties of the normal distribution. Normal distribution where mean, median, mode are equal at this, sorry, the your graph. So this center line will be mean, mode, medium, assuming both right and left are equal. Now the shape of distribution is symmetrical. Symmetrical means this thing. Okay, I'll just shift it to the center. Okay, symmetrical means this right and left has the same area, or these both are identical. Okay, mathematically it can be described by two parameters, mean and standard deviation. As I've told, this is the mean center line and this is the standard deviation. Okay, if data are normally distributed, we go for parametric test. This is just a statement you have to learn. When the data is normally distributed, further we go for parametric test for our research. Okay, while you go through the different tests, you will get this. Okay, this graph are not important. Okay, so next, the second statement, mean of sampling distribution is equal to the mean of population. Okay, this is population, this is sample. Now the mean is coming x. Okay, so it's saying that also equal to the mean of population. So mean of sample is equal to mean of population. Okay, this is an inferential statistic where we are assuming the value of population from the sample. Okay, so that's telling the mean is equal to the population mean. Mean of sampling distribution is also equal to the mean of population. Simple. Now the third is like population standard error. Is telling about the formula of standard error. Sorry, standard error is equal to, this is the formula sentence, standard deviation of the sample, standard deviation of the sample divided by square root of sample size, square root of sample size denoted by n. Okay, so it's the second sentence say is like C is like SD is equal to SD. Okay, but like when the sample size will be less, so it's almost equal to standard deviation. And third sentence, when standard the sample size will increase. Okay, so then like when the denominator is increasing, so automatically the result will decrease. Okay, so when n is increasing, standard error is decreasing. Okay, that's telling simply this. So these are the three statements of CLT. Okay, hope you got this. About the size, if it's greater than 30 or greater than 30, then the sampling distribution will be normally distributed, and the mean of sampling distribution is equal to the mean of population. Formula, it's given, standard error is equal to standard deviation divided by square root of sample size. Okay, hope you got this simple three theorems. If any doubt, you can just comment or you can just WhatsApp me from the number from the description. Okay, so thank you.